Okay, my friends, this is going to be a lot of fun. I love this guy. He's brilliant. I think, though, he may be looking at the Bohr model, though, is still valid, and it is not. The standard model doesn't work. It's electron flood theory is the new model, and that is what I want to talk to him about. Is before you can talk about electricity, you have to understand what is the nature of the electric particle. Now listen to this.
I made a video about a gigantic circuit with light-second long wires that connect up to a light bulb which is just 1 meter away from the battery and switch. And I asked you, after I close the switch, how long will it take for us to get light from that light bulb? And my answer was 1/c seconds.
And his answer is wrong.
We would be able to communicate faster than the speed of light.
That violates causality and common sense.
This is actually a bit misleading.
Misleading in a way.
Extremely unconvinced.
Naughty Mr. Veritasium has sort of a right hornet's nest.
Clearly, I did not do a good job of explaining what was really going on in the last video, so I want to clear up any confusion that I created.
All right, before you do that, Derek, I want to tell you, brother, there is no way that you can explain anything with the current model. Before you can, let me show you electron flood theory and the particles that make up light, which are atomic vapor. And that is what everything is made of, is atomic vapor dipoles. Okay, my friends, we are very close to being proving my electron flood theory. And what is electron flood theory? It says everything is a dipole. And they shut down the Large Hadron Collider to do focusing of particles. And now they are finding the same particles I'm talking about. Let me show you those particles. Okay, this is from Fermilab, and they do the particle collisions, and they have seen these particles, and they know this is a fixed black particle with a haze around it, and then they have a glowy white point particle. That's what they call them from Fermilab, and I agree with that 100%. They have only seen these. They don't know where they come from. They don't really know anything about them, other than that they are there, and then they find other particles. Now, this was done with light, not protons. Protons, are gigantic particles, basically, that come across. They smash with all kinds of other particles, and you get all kinds of debris. And that's what they dig through. And what they have found is these particles. And they have also found this separated from that, which we have done as well. What we did was, instead of hitting beams head on, we forced all of the particles to collide into a very tiny restriction. And what happened was, the white glowy particle, which is not fixed, this is fixed, this cannot change. This is not fixed. It's in glow, as you can see it glowing? The other one's just never going to change. It's like a bowling ball. So this goes back 7 years ago. This was from a video, I just took it off the screen. It was called Dark Energy. Light is dark energy while traveling from the sun to the earth. That's the dark energy. That's the dark matter. It's the carrier. They call it a carrier boson. I agree with that. This carries the light particle. These two are glued together just like a magnet. This is the carrier, which is called a boson. This is the explosive part, which is called a fermion. Not totally unknown. They understand it, they just can't see it. We showed it because we did this. We collided light into a Venturi. And what does a Venturi do? And what is light, first of all? Light is a particle. It's this particle that I just showed you up at the top here. All right. Now you can see, I don't know if you can or not, but this little dot here. Let's see if you can see that. You see those little red spots in front of it glowing? They are charging that particle. They're charging that particle up as it concusses with them. Exactly what happens in a motor. Electric motors, the same thing. Particles in fields are in concussion. That drives the motors. That drives a generator. This is nothing more than the same. This, when it concusses with particles in the air, creates glow and push to shove. This becomes more pushy. It just gets built up and says, hey, whoa, 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 everybody got out of the way. This guy back here, not hitting anybody because the black ball is in front of him. It's protecting him. Well, what happens after this guy gets so upset about pushing into these guys? He says, I'm done. Bloop. This one goes to the front. The black goes to the back. This one goes to the back, the black goes to the front. Now this one begins to charge up. That's called the muon, I don't know if they call it the muon wobble, the flip, whatever you want to call it. But this is the particles they've never seen before, the black particle. Well, they've seen it, but only they've seen it in these collider shots, which give them very little information because it's just a bunch of debris. But they do see them. And here's exactly, that's CERN. That was not me. Or maybe Fermilab put this out, but it's muon neutrinos, the black ball, electron neutrino, the white ball. And then what happens? When they hit the Venturi, pow! They actually literally deconstruct themselves. The muon neutrino becomes a sterile muon. You want to look it up? Sterile muon, all by itself, just sitting there all by itself. And that's very, I was shocked. And then the white, which was the white ball, turns into a shower, which obviously it does. Now that's fission, which means it's separated, and that's fusion, means it came back together. Because they come back, right over here, they come back together. Now they call these interference patterns. They're not interference patterns. This is a single slit. There is no a wave flapping this way and another slit flapping back over and so forth. That is not correct. Light is a particle, it is a dipole, and the white particle, when it splits from the black particle, it says, don't let any other white particles near me. Get away from me. And then they start to set up lines of separation. These are repulsion lines. And if you look at galaxies swirling, you'll see every galaxy has an arm, and in between it has a dark spot, and another arm, and another dark spot. That's their pushing to shoving, push to shove, push to shove, push to shove. That's exactly what you have here, is push to shove. Okay, Derek, just to establish a little credibility, I was in the Army in 1968. I worked on Nike Hercules missiles. I was a power generation equipment repairer, 52D20, which means I had to be able to run all kinds of tactical equipment and gas generators and turbines and all kinds of things, power generation sets. And now, not only that, I worked on Nike Hercules missiles, which means that I wasn't just making electricity for toasters. I was, you know, you have to understand all the implications of nuclear powered missiles, you know, and radar clamshells and all these kind of different things to maintain that equipment and to be sure you're not going to cause a little bit of an accident. Okay, so I was a 52D20 in the Army and servicing Nike Hercules missiles, and I was studying deeply in, because this was when, you know, quantum was really starting. And the transfer of energy is from light to atomic vapor. That I wrote way back in '68. And I went through every bit of atomic physics and the chemistry and energies and bonding and heat and light and all the different constants and you know, all of the things that they just accepted were true about. You know, you say this and you're smart. No. I said, well, let's look at it. No, and it was all wrong. So anyway, I got out of that and went into electronics. You know, that's what I did my whole life. But, you know, I went through light energy and chemistry and heat. And so I'm perfectly well qualified to speak in this. And I can tell you what, they realize nothing is correct. This is Yale. Listen to this. All right, now this is Yale University. I'm going to explain to you the Feynman diagrams because I fully understand them. And listen to what he has to say. He's greeting his new students for the year. And they have all kinds of courses. And you go for free to all of these schools. I went to the University of Geneva free. And you can go, I've gone to Rice University, Johns Hopkins, all kinds of them, because it's free through Coursera. They don't give you a diploma or anything, but you can learn what you can learn. I have learned that I was still correct. I want to see what they're saying, and here's what they are saying. Listen to this.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal.
All right, he's going to make a little joke about saying in a week or so nobody's going to understand quantum physics. Just go home and tell everybody that you know what you're doing, and you'll do fine. And basically, that's what he's saying. And he's right because nobody can understand it because it can't make sense with the current model. Now, let me show you the Feynman diagram. I understand how this works, and they don't. All right, I can show you exactly what these Feynman diagrams mean. They are showing particles coming in like this and smashing, and then all of a sudden particles showing up from nowhere. No, they didn't show up from nowhere. They were attached to black and white particle. They've never seen a black particle before. And the diagram shows what they have seen, these collisions, and then you see these particles come off, but they don't know where the particles came from. Now, these are Feynman diagrams. And listen to how they arrived at these things. This is all the kind of stuff I did to try to show that it wasn't right. And none of this stuff means anything at all. They're talking about scattering and so forth. Yes, when these things collide together, little particles go flying off. But the particles are either the electron neutrino or the muon neutrino. And this is just all gobbledygook. Because are you going to go through this and understand this? Who do you think is going to go through this and understand this? Nobody. They're just going to take his word for, oh, the guy's got to be so smart. Look at all these little things he came up with. And that's what I ran into. Oh, look at this. All right, somebody tell me what this means. Path particle representations. I mean, the guy was probably a nice guy. But when you get down to the end of it, it's just not realistic. Okay, Derek, so now before we could talk about electricity moving, we're talking about speed of light, and I see a lot of things, constants and so forth. Well, what is light? Light is that particle right there. That is a photon. And it's exactly what Fermilab and CERN say it is, which is the black particle, and which is called a fixed particle. And that's all the mass. That's the muon, the dark matter, dark energy, the whole shooting match. That is the hot energy, and that is the electron neutrino. This is a muon neutrino. This is from Fermilab, not from me. I am showing light. Light is way smaller than the particles that they are working with at Fermilab and CERN and Lawrence Livermore, all the rest of them. They're concussing gigantic protons. And when I say gigantic proton, you say, oh no, that's just one little proton. No, it isn't. Because in electron flood theory, a proton is actually made of this, which is a ball of these. In their smallest form, which is a half of one of those. Just like that, the black and white only. That's an electron to us, because we always saw the glowy part. We never saw the dark part. You couldn't see it. It never showed up. And it still doesn't show up unless you do this in a very special way. And this is what we did, was we put it through a Venturi. Now, let's examine what I did do and why I can make these claims and why Derek needs to talk to me. And we need to talk about this and just get it out in the open. If it's right, it's right. If it's wrong, I'm just an idiot. But this is light. These are the particles that we could see using CMOS smartphones. So it's not like we got to do anything big here. This was light from a pulsed red laser. A simple construction laser. A lot of people have them in the house right now. Pip, 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 pip. And that is the wave. And what does the wave signify? The wave signifies that particle I just showed you, which is this right here, coming through the air. Now, what does it hit? It hits all these little particles that are in the air ahead of it that it has to push out of the way. You see those little red ones? Well, that forces this particle to expand in energetic value, and then it can no longer sustain the forward, it flips. This one goes forward and starts to charge. That's what they call the muon wobble. And these are muons. That's a muon. This is an electron neutrino, muon neutrino, electron neutrino. And that is, and again, that is not my saying, that is what, here it is somewhere. There it is right there. You see the black one is the muon, the black ball. The white one is the electron shower. All right, well, it starts out with a white ball. You see the black and the white? So you have the black ball and the white ball together. Now, again, they're smashing huge particles, so they don't know where they come from. I know where ours came from because we was just working with light. That's all this is light. We did not smash any gigantic particles together, so we don't have to worry about all of the things that they're digging through. We are starting with the most basic particles, and most people, even a lot of the physicists, they have no idea. Well, they don't know any of them. That light is a dipole. Light is a dipole, and you could see it. There's no question. The black came away from the white here at the Venturi, and the reason is because the black is so massive it could not get through the slit, and it's these fields that these created. You see these push-to-shove fields here? They were so intense that they ended up squirting right through that Venturi right here. Okay, because this is nothing more than, if you see a Feynman diagram, he shows every one of them has an angle like this and an angle like that. And then all of a sudden things come out and they don't realize, well, yes, they do. But they come out because they're part of the particles that they didn't understand there was two particles together. So they think something just popped out of nowhere. No, it didn't. All right, so now I have just explained the Feynman diagram. Okay, so they are looking for new physics, and I agree they need to look. They need to look a little harder, though. So it's over the past 3 years, the team up LHC, Large Hadron Collider team, upgraded a magnet system to narrow focus of the beams. So what they did was they wanted to bring them into a beam. They were just shooting them down, hoping something would hit something. I showed them long ago, 7 years ago, if you focus the beam, you're going to get collisions. I use light. They are stuck with their protons, basically, because that's what they designed this gigantic thing to do. Now, so they still want to hit protons head on, but they can focus them now to get a lot more data. So that's the key between this whole upgrade for 3 years. It's been upgraded to analyze 30 million particle bunch crossings per second. So they're coming head on still 30 millions a second. What are they going to do? They're going to find just nothing but trash because they're starting with these, hitting these head on. What are they going to find? Some of them they're going to find are going to be chunks like that. Some of them will be chunks like this. Some of them will be chunks like that. Some of them will be chunks, all kinds of different particles they're going to see. We started with that. We see that. We started with the basic. So we never have to see all these big particles and dig through them. They've been digging through this stuff for 10 years. 400 guys for 10 years. Because, first of all, they weren't hitting them correctly. Anyway, let's just go through this. The software has been upgraded to see all these new particle collisions. We added to the LHC existing lineup detectors to look for phenomena that go beyond the standard model of physics. I have that phenomena. I showed it. Such phenomena could shed light on the nature of dark matter. It absolutely does. It's more abundant than ordinary matter. I agree with that. Which is the stuff we see is the white matter. They could confirm the existence as yet unseen supersymmetric particles. It does indeed do that. Extra dimensions. That's possible too. That is possible. And or microscopic black holes. Undeniable, we've seen them. Or a fifth fundamental force of nature. Yes, it's the dipole particle. I've been hunting for the fifth force for as long as I've been a particle physicist Sam Harper, a team member, LHC's CMS detector, told the BBC. Maybe this is the year. It's been a year for 7 years. So Sam, please, let's talk, my friend. I have the electron flood dipole theory, which says everything is the dipole. Now, let me show you what the nucleus is made of. And then I was hoping Derek, I believe his name is Derek Mueller from Veritasium, will look into this because he's good. He really looks into the stuff, which is unusual because I believe he's outside, hopefully, the academic system, which sort of restricts you from making statements because of peer pressure, peer review pressure. And I'm not subject to that. So I've been making all these statements, and so I'm basically locked out. Now I'm hoping that this can be seen for what it is. I'm showing the facts. Okay, just so we can clear the air here, what is a proton, neutron, and an electron? It's chemistry, Libre text, very, very good, very simple, very quick. Now, they're talking about chemicals and chemical reactions and all this sort of stuff. And electrons do basically all of the chemistry. They're the things that they think are attached to a big ball, like one little tiny electron and a gigantic ball in the center, which is the nucleus, which is all positive. Not the case. The ball in the center is not like that, it's like this. And that particle right there is not a single just electron negative, it's a dipole. I can prove this just by using tractor beam magnets. You can see it. The center is so attractive that it wants more electrons, but the electrons that surround the center core, the black core, there's like a black core in here, and then around it is these. Okay, basically if you were looking at it, it'd be like this, and then more electrons would want to try to come in to get to this dark core. They separate. I'm telling you, they separate. And I can show you that in space, they actually do separate charged particles from the dark core. And I can show you that with a black hole in space. I'm going to do it in a second. Now, what happened here? That particle can't get into these because they say, no, we got enough, because these are pushers. And this also has a pusher. All right, so it says no, but they say, we want to get into that. And I say, no, you can stay this far away. You can stay right there. Stay right there. Don't go anywhere. You're okay. We push you, you shove your way in, you can stay there. Let me show you that in a tractor beam magnet in a minute. But the electrons, they say, are located outside the nucleus. They're totally negative. They have almost no mass whatsoever. Protons, they say, are the main particles that make up the atom. Now, neutrons, they say, are almost identical to protons, only they're just a tiny bit heavier, which is, guess what? The exact same weight of an electron. So all it means is, instead of having a ball here that's an uneven number, you have a ball here that's an even number, would be a neutron. So if you had 1839, it would be a proton. It wants one more. But the coding says, no, you can't get through there. All right, so 1839 would say, I want one more. If you had 1840, it would say, no, I'm okay, I'm good. I'm totally neutral. Stay away, I'll stay away from you, stay away from me. But if I'm one of the other, 1839, 1841, 1835, whatever those are, they want to attract or push more away. Let me show you the tractor beam magnets, and it'll become very, very, very obvious. So I just explained to you electrons, protons, and neutrons, and here they are here. And this is just crazy. Electron has almost no mass whatsoever, but exactly the same charge as the protons. The protons are literally gigantic compared to the electrons. Neutrons are basically the same as the protons. See, they're showing the same mass. Well, it's not. A neutron is this mass plus 0.005485. Inside the nucleus, it has a relative charge of 0. I'm good with that. And all it is just a mass that is correctly the right number that's even. This is a negative 1, which is correct. I go with that, the electrons. And the proton, there is none. So there is, this is in, and the electron is inside the nucleus. There is no protons. All right, so you've just been trained. All right, this is it right here. This is Latham's Crazy Machines. Incredible tractor beam magnets. You see what he's got here? He's got a brass ring, which is not magnetic. And let's look at what he's got here. He's got a core of the dark matter, which is the gravity. And he's got the electrons in the outside, which would be attracted to the gravity. And watch what happens. So now he has made a nucleus. That is really what a nucleus is like. It's just like I showed you. And there goes, that's it exactly right there. This is nothing more than all of these electrons around the dark core, which I showed before. And this is nothing more than one more wants to get to that dark core. It can't get there. And it will stay stuck in that position. You could drag it around. All it is two fields interacting. I want to push my way in, they want to shove you out. And the black dark matter in the center is the most attractive of anything. That's why it's gravity, it's dark matter, it's the muon, it's the boson. Right? And when these things go flying away, it's light or heat. Right? So that's it. Alright, I'm going to show you a black hole in space, and the Russians did it back in 2015. Now, let me turn off the sound because it's in Russian. Alright, here we go. It says everything else that's been happening in this black bucket, and the black bucket is a vacuum. Now, the vacuum means there's no extra particles in there. And then they're going to squirt in these charged particles. And then they're going to look and see what do these do. And they expected these charged particles to push everybody else back and forth and end up with a crystal lattice, basically, of seeing these charged particles, everybody pushing everybody else away, similar to what I showed you with the tractor beam magnets. However, that did not happen. And the reason it didn't happen is because they are in zero gravity. These particles can push and shove, and the dark matter goes to the center. Watch this. This is Plasma in Space Experiment, English subtitles, Absolute Ecology. Here it goes. Now, they're going to be talking about, here he goes. He says, instead of a clean lattice, an empty void, an empty void appeared in the middle. Now watch. Alright, so during the experiment, we contacted the Earth guys who couldn't believe it either. So here's what's happened. Now, I'm going to slow this down very slow and go back here 1 second so that you can see what's actually happening. Let me come out here right about there. All right, now, I'm going to slow this down to 25% so that we can watch the bounce. That's the critical thing. What you're going to see is the white is going to collect around here. You see it's going to go bounce, 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 bounce. And more and more and more will collect here. Watch. Boom, 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 boom. And they're starting to congeal in here. See them bouncing up and down, bouncing up and down, bouncing up and down, bouncing up and down. I have a diagram here to show you exactly why this is happening. Why would it bounce like that? And why is that black hole in the center? And why is it collecting more and more white particles here? And less in between here. And I can tell you why. Now, they sent this to one of the guys at Max Planck. And the guy locked himself in his office for 3 weeks because he freaked out. And nobody knows what to do about it either. They still don't know what's going on there. I can tell you exactly what's going on. If we go back to look at this when it was bouncing here. All right, let me turn my stuff back up to normal. All right, now, while we see this bouncing, what's happening? Well, there's a container around here, around the outside. And everything there is coated with electrons. So that container itself has electrons on it. So as this gets pushed away, they're pushing back. Push, boom, 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 boom. And here it is right here. Here's the diagram. And the only reason they're seeing this is because it's zero space, and they started with a vacuum. They squirted these charged particles in, these little white joggers. All right, now, what happened? They try to push away from the walls because the walls are coated, both sides of the walls. Every single thing there is coated on the outside with electrons. The inside is the dark matter. That's why we've never seen it before. That's why we've never seen it. The electrons will always go to the outside. They want to push away from each other. So here's what happens. The dark matter gets forced to push towards the inside. And out here, the white matter pushes up and then it pushes back. It pushes up and pushes back. That's what we were seeing the bounce until it sort of settles in and collects a nice layer of whiteness around the dark matter. All right, now I wrote this, I don't know, a long time ago. micron plasma. I don't know why I calls it that, but it's, well, micron plasma, yeah, it's in them, that works. And it's in zero gravity and a vacuum. That's the key. Zero gravity and a vacuum. All whites push all other whites away. These push, 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 push. Now, that's why the bounce happens. The dark goes to the center only from electrons coating the interior walls. Yeah, the reason it goes to the center is, these red are electrons. The black is the muons. And the electrons push away. They always want to be away. They will always coat every single thing there is. So if you think of anything there is, all you're going to see is bounce back. And the only thing that bounces is the white. So you never see the dark matter. White is the only thing that bounces. That's why you can see totally, absolutely 100% black there. Not a single taste of white. Okay, I'm going to leave it at that. Derek, I would love to hear from you, my friend. I would love to interact, because you could bring this forward, and you have resources. I don't have any resources, but you don't need much resources for this. What I did was less than $500. I'm serious. Everything you saw was less than $500 worth of equipment that we used. The time was exponentially larger than that, and it just takes a long time playing around until you start to understand. And you're that kind of guy. I know you are. I know the way your mind works. I can see it. It's very similar to me. I think, and I say, whoa, wait a minute, whoa. And that's what you did about this electricity. Now, if you can look into my realm, into the subatomic, photonic realm, and then we can discuss it. Because you have the ability to understand this stuff. Very, very, very few people do. Very few. And I applaud you for that, my friend. I am waiting with bated breath. I always wonder, bated breath, what does that mean?